Let's do the practical today. So, do you have a graph paper? You have a graph paper. We need one graph paper. Plot the graph. Okay. Okay. Paper 5 consists of how many marks? 30 marks. Okay. So AS, how many marks? AS is under 30 marks, right? Under 40, they make it under 30, 50%. A2 under 30 marks, 100 marks from paper 4. Okay, the biggest percentage to paper 4. Paper 5 is 30 marks. Okay. So out of 30 marks, you have to do 2 questions. The 2 questions is this: you open up the set 3. I think at page what? Page. Okay, up. I think second or third page. You're going to see this. Okay. Okay, so it's a paper 5, 30 marks, 1 hour, 15 minutes paper. First question is planning. Okay, first question going to be planning. We're not going to do planning today. Today we're going to do the analysis, conclusion, and evaluation question. Okay, so planning 15 marks, evaluation, analysis 15 marks. Okay, so today our first 2, this week and next week, is going to be about analysis. Okay, then after that we go to planning. Okay, so under analysis 15 marks. You need to plot graph. Okay, you need to, data will be provided. Okay, straight I go to the question. Easier. So planning experiment. The C, analysis questions. C is analysis, T is planning. So we go for analysis first. Okay, we go to the first question. This is how your question will look like. Okay, so when you open up the paper 5, okay, the analysis question will be like this. Equation will be provided. There will be equation. Data is given. Okay, so you are not going to go for lab to get the data. Data is provided. You need to make a critical analyzing with the data. Okay, not like last time. Last time you just draw best fit line. Now you have to draw more, because last time whatever answers you give without uncertainty. Now all the answers you're going to give with uncertainty. Gradient must be with uncertainty. Intercept must be with uncertainty. All the answers you calculate later must be with uncertainty. Okay, so more critical analyzing. Okay, so first they give an equation. From the equation, the table column will be empty. You need to fill up the heading. Okay, so data for x and t given. This equation is for what? It is suggested that the period of oscillation of suspended magnet and its distance from the fixed magnet x are related to this equation. Okay, the period of a magnet oscillation and the distance from a fixed magnet is x. So they already done the experiment. They got like this, and the period is found to be 0.01 second uncertainty, and x was found to be 0.001 meter uncertainty. Okay. Now the first question they'll ask, it is very all standard. Okay, first question. Explain why plotting graph 1 over t squared versus 1 over x cubed would enable us to confirm the relationship between t and x is valid for the data in the table. Okay, what they're asking, why, if you plot 1 over t squared, you can plot any graph you like. You can plot t versus x, you can plot t versus x or t 1 over x, any graph you like, right? But specifically go for 1 over t squared and 1 over x cubed for what? Get a straight line. Okay, when you get a straight line, we can prove this equation correct or wrong, correct? So all physics scientists wants to go for straight line. So in first question they'll ask, why plotting graph 1 over t squared 1 over x cubed would enable us to confirm that the equation is correct. Okay, purpose of this experiment is to prove that the equation correct or wrong. Okay, towards the end. Okay, so here, so the answer you should say is by plotting 1 over t squared versus 1 over x cubed, you'll be obtaining a straight line. Okay. Okay, in other words, by obtaining a straight line, where gradient is equals to what? Anyone? Gradient is equals to what? Yeah, k. By obtaining a straight line where gradient is k and y-intercept c would enable us to confirm the relationship. So three what they call points you need to reveal here. Straight line. By obtaining a straight line, gradient is what? Intercept is what? Then we can enable to validate the relationship. Okay. By obtaining a straight line, where gradient is this, intercept is this, would enable us to confirm the relationship. Okay. So use your linear law. The equation is going to be varies. So y equals to mx plus c. Compare, get what is gradient, what is intercept. Then you get the first one. Okay, next. Now come to the calculate and record values for 1 over t squared, 1 over x cubed in the table. Include absolute error 1 over t squared. Okay. So 3 marks. Okay, let's redo that. This is the important part. So what they want? They want is 1 over t squared, 1 over x cubed, and the absolute error for 1 over t squared. Okay, go up. Let's see. Put the tabling. Where is it? Okay. Okay, so the first one, you go for 1 over x cubed, 1 over x cubed, right? Yeah, 1 over x cubed slash, put your unit. What's the unit? Centimeter, is it meter? So meter -3. Okay, meter -3, right? Yeah. Okay. Then 1 over t squared as usual times what? S -2. Then the third one is changes of absolute error of 1 over t squared. Of course, slash is S -2. The heading, right? Okay. Okay, now get all your 1 over x cube value. The 1 over x cube value follow the same rule. What are you going to check? The x value, you just cube it, so 1 over x cube, right? But the answer you give here, you must follow what? Significant figure or the decimal place? Significant figure, right? Calculated afterwards. So you follow significant figure. How many significant figure to write? Same rule. The significant figure of the source. Who's your source? Source your x. X, how many significant figure? So all like looks like 3. So we go for 3 significant figure. So now x cube is all 3 significant figure. So all of them looks 3 significant figure. 0.350 is actually can say 2 or 3. So we take it 3 now, all standardized 3 as okay. So on x cube, all are 3 significant figure. Okay. You don't need to do all. Okay. Just speed up my teaching. Okay. Get the first reading first. 1 over x cube for the first reading, how much? Anyone? What is the first reading here? 20? 23.3. Okay. So 23.3. Okay. Okay, now can someone get me 1 over t squared? 1 over t squared. So 1 over t squared, same, follow significant figure. How many significant figure to write? Check the source. Source, how many significant figure? 3 SF. So 1 over t squared also 3 SF. Anyone? 0.411. 11. Okay, so this is easy. The old concept. Okay, now comes to the something new. Error. Find the error of 1 over t squared. So how to find the error for 1 over t squared? Okay, there are two methods. Okay, two methods. The first method is you create an equation. Create equation for uncertainty equation for 1 over t squared. Okay, like for example, okay. So you got 1 over t squared. You want to find uncertainty for 1 over t squared. Okay, you create equation y equals to 1 over t squared. Make it y equals to 1 over t squared. So changes of y over y is what? If y equals 1 over t squared, changes of y over y equals to 2, right? 2 changes of t over t, correct? Your second topic, knowledge. So what is your changes of y? 2 changes of t over t times y. So changes of t over t. Y is what actually? This is y, what? This is y, right? Replace the y. Y is 1 over t squared. So what is the changes of y? So 2 changes of t over t cube. Yes. Okay. Get an equation to find uncertainty. Of course, we are looking for this. We are looking for uncertainty of 1 over t squared. But 1 over t squared, I kept it as y. So actually, changes of y now I'm looking for, right? Changes of y is actually changes of 1 over t squared. Correct? So this actually is same as changes of 1 over t squared because I replace y as 1 over t squared. Okay, so now use this formula. You can work out your changes of 1 over t squared. So what's the formula to be used? 2 changes of t over t cube. Okay. So what's your first data will be? Okay, let me go back. So remember this equation. In exam, you have to derive it. You have to derive it. I take 1 or 2 minutes. Okay. So 2 changes of t over t cube. Okay. Get the first uncertainty now for the data. Go back. Okay, now get me this answer. So the changes of 1 over t squared is found to be what? 2 changes of t over t cube. Right, we found. Okay, 2, okay, fine. For the first data, include the value 2. For the first data, changes of t, how much? Changes of t is 0.01, right? 0.01. Period, how much? Period is 1.56. Okay, 1.56 cube. So whatever answer you got, we'll place here. Anyone got the answer? Any mistakes? Found any mistakes? That's a mistake. Changes of t is period 0.01. That's your changes of t, right? This is your t. This is your t. It's your changes of t. Okay, so anyone got the answer? So 2 times 0.01 over 1.56 cube. What's the answer? What? 5.27. 10 power of negative 3. 5.27. So 0.0005. So you got 0.005 something, correct? 0.0556. 52, so 5. 5. Okay. Okay. Okay, so that's something different now. I don't know why Cambridge changed. Last time was the rule for uncertainty, one significant figure. Now the error can have more than one significant figure. They allow. Okay. Last time, if error got 2 decimal place means actual value follow the error. Right. Now the playmaker is the value. Value never follow the decimal place of the error. The value follow source significant figure. That's it. Source significant figure. So now 1 over t squared, how much? How many significant figure? 3 significant figure. Why 1 over t squared you go for 3 significant figure? Because source t is 3 significant figure, right? So now, so 1 over t squared you got 0.411. That's it. You're not going to change that anymore. That's the final answer. Okay, last time what you do, the value you're going to adjust the decimal with your error, right? A2, we never do that. A2, just significant figure, that's it. That's the ultimate answer for the value. Okay, now the error, right? Error, let's say in this case, error is just nice, like get 3 decimal places. The value is 3 decimal places. The error also, we got 3 decimal places, just nice. Sometimes error you might get, let's say for example, here you got 0.005. Let's say you got 0.1. Okay, let's say you got 0.1. Just now you calculate 0.005, you got 0.1. What AS you will do? The 0.411, you make it 0.4, right? Same decimal place. Now A2, 0.411, no change. You leave it as 0.411. The error, right, which you got 0.1, you add another 2 zeros at the back. make the error adjusted to the value, decimal place. Okay, so now the kingmaker is the value. Okay, I don't know why they changed it. Okay, this is the rule they follow for A2. A2 value follow the significant figure of the source. That's it. No changes anymore to the decimal place. Error if the decimal place lesser, the error try to follow the decimal place of the value. Okay, the error is 1 decimal place, value got 3 decimal place. Error make it add another 20 at the back, make it 3 decimal. Okay, the error will follow the value. Okay. Okay, so this is how you find the 1 over t squared. This is one way. Okay, there is another one way. Okay, another one way to find this value. Okay, the second method. Okay, the second method is changes of 1 over t squared, right, is equals to the 1 over t squared value of maximum minus 1 over t squared value of minimum. This is your uncertainty. This is another method. 1 over t squared maximum. The maximum can be for 1 over t squared. How to get 1 over t squared maximum? So 1 divided by, when 1 over t squared become maximum, the t squared minimum or maximum? The t squared must be minimum, right? To make 1 over t squared maximum. Because t squared is the denominator, right? Max what you call numerator, denominator. Denominator smaller, the value get bigger. So here t max we use t squared down here minimum. T squared down here minimum. The t is minimum. The t minimum, the 1 over t squared will become maximum. Correct? So for your first data, how to find 1 over t squared maximum? So 1 divided by, what is the minimum t can go for the first data? What is the minimum period can go for first data? First data is 1.56 plus minus 0.01. So the 1.56 can go lowest to what? 1.55. Highest can go 1.57. Okay, as a range. So here t we put the minimum. So we put what? 1.55. 1.55 square. 1.55 square. The data, the lowest can go, the minimum can go is 1.55, right? 1.56 minus 0.01. And this is lead to 1 over t squared max. Minus, now 1 over t minimum, 1 over t squared minimum. So t here you must put maximum value, right? So how much you put? 1.57 square. Okay, calculate this. This is your changes of 1 over t square. Second method. Maximum minus minimum. These got around 0.005. How much you got? 1 over 1.55 squared minus 1 over 1.57 squared. 0.01. 0.01. Big difference. 1.55 squared minus 1.57 squared. You square the value. Our early equation wrong. Correct one. So y is 1 over t squared. Changes of y over y is 2 changes of t over t. Y bring the other side. Y is 1 over t squared. So 2 changes of t over t cube. Correct? 2 changes of t over t cube. Well, you get a big answer, big differences. What is the data you should get? T square. Change of over T square. Why the second method should work? Teaching for more than 12 years this concept, no problem. Yeah. Okay, so two methods. The second method also should work. Okay, so choice is yours. Okay, maybe this time it should work. Check your calculator. Your mode is correct. All of you got the same answer, 0.01. Cannot be wrong, man. Okay, so both works actually. So, but of course the equation will be more accurate. Okay, but most of the students found that the second technique easier. Okay, so choice is yours. Okay, so you got the first data 0.005. Okay. Okay, class. Now I give you 2 minutes. Come on, calculate all the data. Okay. Don't record down from here. You calculate first, then check from this slide. Get the data correctly first. Okay, you calculate. You calculate one by one, then check the data. Okay. Yeah. 74.2, huh? Yeah. There's some slight change. So here you got 74.2. This what you got? 58 point. Okay, let me. Okay, you complete everything first, then we see which one got changes. One over T squared, first one correct, eh? Third one, eh? Third one, how much you got? Oh, 482, slight difference. So 0.482, eh? 510. Then? Oh, yeah, also. This one, eh? 74.2. 58.2. Okay. Okay, your table wrong, your data wrong, it's going to be a chain reaction. You're going to lose lots of marks. You're going to affect your graph, you're going to affect your calculation later. Okay, plus. So I hope all of you got that up. The second method, I think I made a mistake. Second method, I told you what? 1 over t squared max minus what? 1 over t squared minimum, right? Oh, no, not max, sorry. Actual. Actual minus minimum. The actual value minus minimum. Sorry. So the changes of 1 over t squared. So always actual minus minimum. You can go actual minus maximum also can. So actual means you put for the first case 1 over actual t squared. Actual t is 1.56. 1.56 square minus 1 over minimum. Minimum is how much? Minimum means here should be maximum 1.57. Then I think you should get this value. Actual minus extreme value. Actual minus minimum. Two methods, both method works. Sometimes a slight differences can arise, but they accept both the mark scheme. Okay. Oh, continue. Okay, so ready for the next few steps. Okay, so let's continue. Back to the question. Okay, so we done the part B. We done the part B, 3 marks. Okay, now after that, now plot a graph of 1 over t squared against 1 over x cubed. Include error bars for 1 over t squared. Okay, no need to worry about error bar. You plot as how you plot last time. Okay, just transfer the data and draw the best fit line first. Error bar, you draw first, then I show you how to draw the error bar. Just do as usual as you did what you did in AS. Okay, in a real examination, one good news is this question, this is the graph, okay, but in your real examination, this set towards the end, the scale is provided for your exam. Scale provided, so you don't need to worry about scale. Okay, how many boxes need to take how many centimeter? You don't need to worry about that, because, for example, let me show you the few end questions like this. You see, so this is one of the pasya. So the scale at the side is provided. Okay, in a real examination. But this first question don't have scale. The scale I want you to follow, all of you, is the scale. So follow the scale stated here. You plot 1 over t squared versus 1 over x cube, right? Yeah, follow this scale, follow this scale. So your x, which is 1 over x cube, start from 20, start here 20, scale start with 20. So each box is 10. So one box later is 30. One box later is going to be 40. So each box is 10. Why start with 0.4? Why start with 0.4? Then every box is 0.02. That means 0.4. Next one is what? 0.402. Sorry, 42, not 402. Should be what? Should be 0.42. Every one box. Every one box is 0.02. 0.42, 0.44, 0.46. Why? So real exam scale provided. So big problem solved, but another problem arises. What's another problem? Examiner easily can check whether you are right or wrong because all the graph need to be identical. Okay, any marks, so they easily can catch you that you are wrong. Because all of you using the same scale. Okay, now transfer the data, plot the best fit line. Don't worry about error buffers. Transfer the data, plot the best fit line. Okay, transfer your coordinates, plot the best fit line. Okay, class, so let's go for the error bar. Okay, so part C, we want you to include the error bar. Okay, what is error bar? Okay, we go to the graph. Okay, from the graph, your first data, this you start with what? 0.400, right? 40, so here you got 0.42. Then here start with 20. This is 20, this is your 30. Then goes on. Okay. First coordinate is 0.411, right? 0.411 vertically, right? 0.411. What is your x? 23. 23. So 23, 411. 411, I think somewhere 5 boxes somewhere here. Okay, somewhere here, let's say cross. Okay, error bar means how much the value has been as a range. How much range the value, how much of the range it has. Okay, so your y value is how much? The y value from the data is 0.411 plus minus how much? 0.01, 0.05, right? 0.05. Oh, 0.005. 0.005. So that means your value, maximum value, this data can go is max can go how much? 0.416. Minimum can go is 0.406. Correct? 406. So you have to show this range. So what do you have to do? This is the coordinate, actual coordinate, but it can go up to how much? It can go up to 416. 416, how many boxes? 8, right? 5, 3, 6, 8 now. So you're going to extend this up to 8, the 8 box, 0.016. You must draw a line. Down you must draw another line. Like this. The line should be like this. Cross, right? The original data you must draw. And you must put a flattened horizontal line like this, like I. This is your 0.411, your actual cross. This will be your maximum value. You can go 0.416, and this will be 0.406. This is called error bar. The shape of the error bar must be in form like an I. And the horizontal line here, you can go up to 1 box of width. One small box, one small box of width. The horizontal line, small box, one small box of width. The horizontal line of the error bar, just one small box. Okay, one small box means like this. This one small box. This is like one small box. This is the size of error bar. You can go down, then another one small box. Okay. So this is the first error bar. So for all the coordinates now, you put their respective error bars. Check maximum how much, minimum how much. Draw a vertical line and a flattened line like I. Draw error bars for all the coordinates plotted. It's called error bar. Or two type of error bar, vertical and horizontal. This one was vertical. They give the y value error bar. Sometimes they give x value error bar. We did that later. Okay, so every coordinate you're going to have an error bar. All data you're going to have error bar like this. Error bar. Okay. Error bar. Okay, the horizontal line I draw very long, but actually it's one box only, one small box, the one shown on the right. Okay, so all of you done with the error bar. Okay, now let's see another one, something new. This. Okay, so now, so I draw a error bar randomly. I got one error bar here, got one error bar here. Okay, you have another one here. Okay, you have 6 error bars, right, altogether. Okay, now what we're going to do, we're going to draw another line called worst fit line. Okay, worst fit line. Okay, that's fit line, you know that before, but now we're going to draw worst fit line. What is meant by worst fit line? Worst fit line is the greatest gradient, the most extreme gradient you can draw, a line you can draw with the most extreme gradient within the error bar. That's called worst fit line. We always go, we can go the lowest gradient or the highest gradient. Let's be standardized. We go for the highest gradient. Highest gradient within the error bar. So what do you have to draw? The worst gradient. That means you put your ruler location. You have the first error bar and okay, let's say you have the 6th error bar. You have the 6th one. This is the 6th one. This is the first one. The first one and 6th one. To get the worst line, you place your ruler at the tip down here, this point, at the lowest point of the first error bar. Okay, your ruler. Let me change color. Change color. Oh, sorry, cannot. Oh, yeah, again. Okay, so you put your ruler here, the lowest, and put the ruler at the highest of the 6th error bar. So you place your ruler like this. Okay, ruler edge like this. Okay, it's a ruler. Okay, hopefully I draw one. Good to have a transparent one. Okay, then what you do? You put the lowest to the first error bar, lowest edge of the first error bar, and the top edge of the last error bar. Okay, place the ruler first. Okay, that should be the greatest gradient possible within the error bar. But don't draw yet. So after you place the lowest and the top of the last error bar, you must check the line you're going to draw, about to draw, must pass through all the error bars, must cut all the error bars. Okay, must cut all the error bars. Let's say for example, one error bar was like this. Let me add one error bar. One error bar. One error bar here, the one I draw just now is all cutting the error bar. You see, the second one cuts the straight line, that line, so it cuts the error bar. Okay, let's say you have another one like this. You have another one which is okay, somewhere here. Okay, put another one like this. Got another one fall here. Okay, so this error bar has missed out. This error bar is already above, the line goes above that error bar. Okay, so the line you draw is not worst fit line yet. Okay, you must cover all the error bar. You must fall within the error bar. Remember, if this is the error bar, your line, if your line just cut this line, okay, this consider okay, correct. It cuts the error bar. If your line cuts like this, cut the horizontal line but never cut the vertical line, this never crosses the error bar. Crosses error bar means it must touch the vertical line of the error bar, not the horizontal line. So here you never cut this error bar. So what do you have to do? You must reduce the gradient now. Okay, so what you do? The lowest one, this edge, don't change. Okay, this location don't change. Just keep it at that lowest point. The upper position, right? This position, we just move it down a little. We just move it down a little. Okay, move it down a little until the ruler edge, right? The ruler edge will come down. The ruler edge will come down slowly until it touches here. That means your ruler now position is like what? So this edge is still the same. Like your ruler position is like this originally. Now this position is still keep there. You put the ruler something like this now. Lower it. Lower it. Lower it. Now the error bar which never touched now able to touch. Okay, so you have to bring down until it touches here. It touches here. That means your ruler going to be like this. Your ruler going to be like this, somewhere like this. Okay, something like this. Then you stop. Okay, it touches all the error bar. Then you draw a straight line. That's your worst fit line. Okay. So the first error bar lowest point and the last error bar top point. Place your ruler first. Check is it past all the error bar. If one error bar is not passed, you have to adjust the gradient. Maximum gradient you have to reduce. How do you reduce? The lower point keep, the upper point you shift it lower. You just push it, the ruler down. Like to pivot it at the bottom. Ruler bottom is pivoted. You can rotate it. Bring it down until it touches the error bar. Once you just touch the tip of the one never touched before, done. Draw a straight line, worst fit line. Okay, you got two lines. One like this. Sorry, another one like this. Sorry. So let's say this is your best fit line. You have to label it. This is your best fit line. You have to label it. Best fit line. And at the tip you can label it. Worst fit line. Exam you have to label it. Which is which. Okay, class. So another one case. Okay, you just follow this line. Do you get anomalous? Do you have any point like when you try to adjust down to fit the one which is missing, but when you slide down, one other error bar was like out of the order. You never connected. You have that case, this experiment. If it happens in your exam, when you scroll down, go down, but you try to achieving the second one which is not overlapping, going down. But for this, but you are another after you go down, touches here, you see another error bar like not touching. That means what you have to do, one of the point you must round it, make it as anomalous. We ignore it, one of it. Okay. One allowed as usual. Okay. Remember, you get anomalous, the other of your friend never get anomalous. Okay, so you're going to lose mark, although you put anomalous. Because of what? Same data, same scale, so all of you should get the identical graph. Very easy for the examiner to get you when they mark. Okay, so nobody get, majority didn't get anomalous, right? Anyone got anomalous? Yeah. So all never get anomalous, you get anomalous, something wrong with your plotting. Okay. Okay, so now done, major job done. So we go back to the question. Question is okay, so we done the plotting the error bar, we drawn the best fit line. Okay, now here they never ask you to draw the worst fit line, but you have to draw one. Marks given for that. Okay, why you need to draw worst fit line? What is the purpose of worst fit line? To find uncertainty for all your values. Gradient plus minus how much? The plus minus we found from the worst fit line. Worst fit line. Okay, first part 3. Determine the gradient and y-intercept of the line. Okay, include errors in your answer. Include errors in your answer. So what you have to do? You have to find gradient. Oh, this is the next. Okay, you can do here. Okay, you do here. Okay, gradient of best fit line. Gradient of best fit line. You underline. Work out the gradient. Get the gradient. Okay. Of course, y2 minus y1. X2 minus x1. Get the gradient for the best fit line. But at the same time, at the side, you must find the gradient for worst fit line too. Worst fit line, the same treatment. So find the gradient for the worst fit line. This worst fit line, this best fit line. So this is entirely the coordinate you must take is coordinate of worst fit line. Okay, worst fit line. So y2 minus y1 over x2 minus x1 again. So you get gradient for the worst fit line. Best fit line, worst fit line. Both must be done concurrently. Okay. Let's say the best fit line you got 2.48. Let's say, for example, worst fit line you got 2.50. The gradient. For example, this for example. So the gradient answer will be what? The gradient answer will be the best fit line answer 2.48 plus minus your gradient, right? Your uncertainty must be the differences between these two values. So the differences, what are the differences here? 0.48, 0.50, 0.02. This is your uncertainty. The differences between best fit line and worst fit line, the differences is your error. And here, your answer always go 3 significant figure. Okay. The error follow the decimal place of the value. What I'm saying, let's say your value, this case you got, this case just nice, right? For both are same decimal places. Let's say, for example, you got the value is 2.48 and your error you got 0.1. Okay, calculate you got 0.1. So what you do? This you still keep it as 3 as 2.48. The error, right? Error you try to make the same decimal place. So 0.10, like that. Now the rule is error can go more than one significant figure. Okay, new rule. Rule for A2. Okay, error can go more than one significant figure. So paper 5, after your graph, all the answers, put in all your final answers, all put in 3 as a 3 significant figure. Error decimal place, follow the decimal place of the value. Okay, so draw true triangle on the graph, get the gradient for both best fit line, worst fit line. And do the same thing for y-intercept too. Y-intercept of the best fit line, y-intercept of the worst fit line. The best fit line, y-intercept is the answer. the differences between best field line and worst field line, y-intercept is the error. Final answer, actual value 3 significant figure always. The error follow the decimal place of the actual value. Okay, so this is your, sorry, this one. Okay, from the Excel plotting, this is the answer we obtained. So you should get the gradient as this what? Yeah. 2 times 2 plus minus 0.1 times 10 power negative 3 or 0.002 plus minus what? 0.0001, correct. Yeah. So this is what you should get. Real exam, this answer 0.05 plus minus around 10%. Okay, you get mark. The error, they don't care about error. They don't care about actually, they never give any mark for the error. Plus minus, what the mark scheme they put, they say don't care about the values. Check the answer, final answer is within the range. Okay, and error, they never talk about error at all. They say to find the error, the method of finding the error, give mark. Method of finding the error. I mean, do the student write best field line, worst field line? Do the student minus the best field gradient, worst field gradient differences is the error? The method, I give mark. Okay, they don't care about the error, what value you get. Okay, always marking they put method of finding the error. Give mark. The worst field line gradient is not to say off. As if the worst field line gradient is off, yeah, your error gradient is complete error. Yeah. But the method to find the error, best field gradient, worst field gradient is shown. You find the difference as your error. That method you get mark. Not even once I come across they give a error value. Okay, they always say how the student find the error, what method they use, that given mark. But the value, right? The value they give range. Okay, in this case, the 0.002, they give range. Normally 10% lah. So you check your gradient. Do you fall plus minus 10% of 0.002? Then you get the accuracy mark. All the calculations after that all make it clear. Normally correct. Okay, after you've done your gradient, go for y-intercept, do the same thing. Y-intercept of best field line, y-intercept of worst field line. Do side by side. The final answer is, the best field line answer is the final answer. Put in 3 significant figure. The error is, The best field line y-intercept minus the worst field line y-intercept. As you have same method. So check your error y-intercept. Do you get this answer? You get this answer. 0.363 plus minus 0.007. We don't care about error 0.007, but the value 0.363 plus minus 10%. Okay, so move on. So y-intercept gradient, the unit, you can put the unit at the side for y-intercept gradient. Practice, it's a good practice to put unit always. But normally marks not given for unit for y-intercept and gradient unit. Normally they check unit for the next question, and the gradient is used to calculate something else. Then they check the unit over there. But I really appreciate if you still put the unit for the y-intercept and gradient. Better put the unit. Cannot trust Cambridge. Suddenly they give unit answer for the unit. They give mark for the unit. Normally mark for the unit only given for, not for the gradient y-intercept. After that. Okay, after that. You might use gradient value to calculate something else. For example, for the part D. I think you are already in part D. Part D, find the value of K and C. Include errors and units in your answers. So K and C. You know y-intercept, you know gradient. Can you find K and C? So you go up, check your formula. So what is your K actually? K is your gradient, right? So 1 mark given when you show the relation. Relation is what? K equals to gradient of the graph. 1 mark. Show the relation. K equals to the gradient of the graph. 1 mark. And in this case, nothing to calculate, right? The gradient value, you just put it down as your K answer with unit. Unit, you're going to check now. Okay. So K equals to the gradient, 1 mark. The gradient value, just put it down with unit. Okay. Now unit, they're going to check. And same thing goes for C. C, write the relation. C equals to y-intercept of the graph, 1 mark, the relation. And yeah, just transfer the y-intercept value down here for the C and write the unit. What is the unit for y-intercept? Same as 1 over t squared, second s negative 2, right? Y-intercept s negative 2, gradient is s negative 2 meter cube. S negative 2 meter cube for gradient. All the answers write in 3 significant figure. After you graph, all write 3 significant figure, your final answers. Error follow the decimal place of the value. Okay. So you must, this is one question. One question, you must, 1 hour, 15 minutes, your complete paper. You must finish this question. I think suggested half an hour. Okay. You spend half an hour for this. Okay. And another 45 minutes, we go for planning. If you can finish this fast, you can go planning. You can take more time for planning. Okay. But now longer because first time. Okay. So last part, then I stop. We go to the next one. We're not going to do entire thing. Just the table only. Just the table only. Okay. Spend 10 minutes, then we stop. Okay, so I'll leave it to you entire thing. Okay. I need to tell you something here. They only give 2 columns here, 2 columns to fill up. But when you check bottom here, they want you to calculate t squared h squared, and include error bar for t squared h. So we need 3 columns, but they only give 2 columns. So what do we do? The 2 quantities we put it together. So what 2 quantities we put it together? The error together. So first we go for what? First we go for maybe h squared slash the centimeter squared. The other one is t squared h, right? And t squared h plus minus changes of t squared h together. Okay. So slash the unit second squared centimeter. Second squared centimeter. So all the value here plus minus, you put both together. Okay, get the first data, then I show you the table. The first data correct means the others should be correct after that. Try to get the first data for me. This one, t squared h, and it's error, mainly the error. 2 methods, either find the formula or the second method, actual minus minimum. So y equals to t squared h to form the equation. So changes of y over y, write your uncertainty formula. 2 changes of t over t plus changes of h over h. Okay, then changes of y is what? 2 changes of t over t plus changes of h over h and multiply by y, right? And your y. So changes of y is what? 2 changes of t over t plus changes of h over h multiplied by your y. Y is what? T squared h. This is the formula. Quite complex. Or second method. So second method is what? The changes of t squared h is equals to t squared h maximum, actual minus t squared h minimum. For t squared h minimum, the inside also must be minimum, right? T must be minimum, h must be minimum, so that t squared h become minimum. Yeah. This is the second method to get the uncertainty. So first data t squared h actual, put the actual t and h now. Actual t is 1.7, actual h is 47.5. T squared h minimum, use the t minimum and h minimum. T minimum is 1.7 minus 0.02 T minimum. So 1.68 to be used here for minimum. H must be the minimum. Minimum is how much? 47.4 minus with the error. And make sure the significant figure followed for the values. H squared looks like all of them are 3 significant figures. So I think this go for 3 significant figures. T squared H, the significant figure must be how much? This is 3, this is 3, so also looks like 3. The significant figure is can varies, depend to the data. Every line can have different significant figure. Leave it to the IU. No need to convert. Just leave it as centimeter. If they give centimeter, just prolong, continue with centimeter. Okay. Because the graph also they can put centimeter. So you follow centimeter towards the end. If it's final answer gravity, you will get centimeter per second square as your answer. Okay, show you the data. Hope your data and the one I'm going to show you about the same. Might be slight difference. Okay, show you the data. Which equation is this? Okay, T squared H. This one, right? This data you got? The first one, I think those who attend the first one. T squared H squared is 5. The error for T squared H is 4. If you got 4, then good. T squared H actual minus T squared H minimum. You get 4. The second method, right? The second method. Can be a slight difference. Okay, so this question going to be homework. Okay, the remaining you do as homework. Take down the scale you have to use. Scale you have to use for the y-axis is 700 to 2700. You plot H squared versus T squared H, right? What is the graph say? H squared versus T squared H. What graph they want to plot? Okay. Let me check the question first. Sorry. Question was T squared H versus H squared. Oh, mistake. Okay, this is for your x, this is for your y. T squared H versus H squared. So t squared h should be your y. Y is 60 to 140. Yes, makes sense. So take down the scale. X is start from 70 to 2300. Y is start with 60 and 140. Every box is 10 by 10. X start with 700. Every box is 200 of interval. So 700, 900, 1100. Okay. So use this scale, and you want to take down the answer also can. After you're done, you can check your answer. It says gravity must get a gradient. Gradient must get 820 plus 50, or gravity. Gravity must get 820 plus minus 50. Y-intercept is 29 plus minus 4. K 24 plus minus 2. Okay, so this is your homework. Give a try. So I discuss next Thursday. Any questions? Yes? Okay, no problem. Good. Okay. Stop here.